Welcome and thanks for joining us. My guest today is Jared Shepard. He's the founder and CEO of Hypori. Jared, good to have you with us.
Appreciate you having me.
And I want to talk about mobile devices, mobile device management, security, and the whole complex of issues that DoD is facing as these devices proliferate. What are the big trends and how do things look going 25 into 26 for the best way to keep these things secured and useful to the warfighter and to civilians?
Sure. I mean, and by the way, this is not a unique problem just to the DoD. It's the idea of the fact that the world is changing. If you look at internet traffic now, there's more internet traffic, significantly so, generated by mobile devices. People spend more time on their mobile devices than they do on any other device. It's their preferred method of communication now. I saw a number somewhere that there's a significant percentage of young men and women under the age of 40 that don't even own a laptop anymore, right? So the world is changing and it's moving more and more mobile. In the department, of course, has the very unique challenge that they are faced with not just being able to enable communications, but they have to enable communications securely, knowing that they have adversaries or nation-state actors who are constantly trying to exploit information. So our approach, I'm sure like one of the big buzzwords everybody hears about now is zero trust. Mm-hmm. Zero trust is a methodology. There's a lot of people that talk about how that methodology is implemented. We also hear these things like CMMC, which is like how does industry have to implement what is ultimately zero trust methodologies to ensure that they have some level of security. Our approach that we decided to address was the edge device, which is that mobile device, this thing. And it's to protect it by essentially not allowing it to interact with the data. So with no data in transit, no data at rest on the edge device, our platform by default assumes that the edge device is already compromised. It was built for a unique mission set in the Department of Defense and then has grown outside of that, where we solved this really hard problem of like, how can you effectively command and control from any edge device without risking the enterprise? And what we figured out was, kind of by accident, but now we defend it as if it was our original intent. If you assume that the edge device is compromised and you never allow the edge device to interact with the data, in other words, all it's doing is rendering pixels of the data, never actually in possession of the data. If you assume that that's what's happening, then the side effect of that is you also get to keep your privacy. Because if we don't trust your device, we don't want to know what's on your device. So what you do with your device is your business. And we protect the department or the government or the enterprise from things that are on your device, and we protect you from overreach of the enterprise into your personal life.
So data processing, if you will, occurs only in the data center or cloud, never on the device.
That's exactly it. So it's you're essentially getting a picture of the data that you're interacting with, pixel by pixel encrypted, writing over itself constantly. You're interacting with it, so that touch, type, and swipe is implementing a change to that data, but none of that data actually exists on your edge device.
It's almost like a terminal.
It's like in the old days when we had mainframes and dumb terminals. We've essentially created a mechanism to make your edge device into a dumb terminal. Wow,
you might call that smart terminal emulation or something. We have a new phrase here.
There's all kinds of words out there for virtual desktop infrastructure. We are being called sometimes virtual mobile infrastructure. Mm-hmm. So yeah, absolutely. It's beauty in the idea or the simplicity of the concept. It's definitely not simple in its execution.
Right, that's the secret sauce, and that's what you're bringing. And this also helps the efficiency and keeps costs low, something DoD and every federal agency for that matter is focused on, you might say, these days. Yeah. Tell us how it does that.
It is. So it's a win across the board. Hypori enables a highly secure access from any edge device anywhere with no data in transit, no data at rest. And because the actual machine itself, the virtual machine, operates in cloud, we can use the power and the efficiency of the elasticity of cloud, right? So we can turn them on and turn them off, spin them up and spin them down, which means we can, by order of magnitude, offer a much cheaper ability to access a virtual device, a fraction of the cost of what it would cost, to provide the device, much lower risk than using something like MDM or MAM, and complete privacy for the edge user. So it's kind of a win across the board. A fraction of the cost of a mobile device, you get to keep your privacy, we get to protect the enterprise.
Yeah, so this really does have application beyond the military situation, I would think.
Absolutely, yes. So I mean, we talk about it. Like, I think Hypori could potentially redefine the way the edge works. If you think about the Hypori virtual machine, when a Hypori virtual machine is running and you're interacting with from an edge device, one of the parlor tricks I love to show is like, how fast do you think this is? And okay, I have 3 bars of 4G, so I think it's 30 megs or 40 megs. And then we show it and it's gigs, 4 gigs of throughput. Well, how is that possible? This physical device could never actually do 4 gigs of throughput. Well, that's because the VM exists in cloud, which means our operating system runs at the speed of cloud. So we're actually giving you a device that runs at the speed of cloud in your hand.
Right, so the cloud is only sending back, as you said, this encrypted, small, pixelated stream.
Delta pixels, actually. So even then, it's just the change pixels. So as pixels change on the edge device, we send those new pixels and they write over themselves, encrypted pixels. So even if there was an aggressor of some kind that was intercepting, if they were intercepting delta pixels, all they get is moving blobs. So they don't ever even get a whole image. Even if they could in real time intercept the entire image from start to finish, all they would get is an encrypted picture of what you were looking at the time. They'd never actually be in possession of the data.
Right, and so the idea of the contested environment or the austere environment that you hear about so much in DoD, this seems like it would be an enhanced way to have the answers you want at the edge in those contested environments.
Sure, so it's a double.
Because of the low bandwidth required.
Absolutely, low bandwidth it definitely performs well in. It even does decent in latency until you start to get really high in latency. I joke, I say Hypori has, just like Achilles had 2 heels, so do we. One is connectivity. You have to be connected for Hypori to work. 2 is the quality of the network. And when I say quality, I don't mean speed of the network. I more mean like if you have a lot of packet drop or latency, that will impact the user experience. But when you start to think about the dynamic nature of the Department of Defense's environment or federal government's environment or just commercial environments, the idea that I can enable anybody on the edge to interact with my secure environment in a way in which they can't jeopardize my data enhances my ability to do my mission. So in the military, we often hear things like not just BYOD, which we are now for the Army, for the Air Force, and for Space Force, hopefully soon for the whole department, but also think about like what's called MPE or mission partner environments. We go into an environment, it's going to be a coalition operation, it's going to be country A, B, and C plus US, heck, add NGO A and B and volunteer organization C. How do you allow them all to collaborate in the same environment in a rapid way? Well, you know what they all have? Smartphones. And instead of us having to furnish and buy equipment, radios, laptops, everything else like that for all these participating entities, you just simply tell them to bring their smartphones through a relatively simple process of scanning QR codes and account creation. Now all of a sudden they're collaborating in your secure environment.
So this then has the potential to really help not just communications effectiveness, but mission effectiveness.
Absolutely. So I mean, this was born as a SOCOM tool set, inside of special operations. It's still in use there today. What we've solved was this really hard problem, and then we figured out, well, maybe actually a more impactful way is to solve a much easier problem, which is the idea of BYOD. How can I enable a federal employee or a Department of Defense service member to access or interact with an unclassified network from my personal device? And while we are an NSA CSFC environment, which means that we are actually a classified mobile platform provider, way more people interact on the unclassified side of the house every day. And the requirement for that is so much broader. And so when you think about the infrastructure savings, the cost savings of reducing that infrastructure and exposure is just by order of magnitude larger.
And just briefly, what are the technical requirements for the device? Is it simply just an app that's on the device? And
it's actually a highly modified version of a TLS tunnel. So ultimately an encrypted tunnel. That tunnel is what you would view those pixels through. It'll work on any edge device, so you can use Android or iPhone. You could use your tablet, you could use your iPad, and all get to that secure environment. In fact, like for instance, on my phone, I actually have 5 different phones on my environment to include the Department of Defense's NIPRNet on my personal phone. So not only does it give me access to a secure environment, but I can actually access a multitude of secure environments depending on what the enterprise requirements are of the edge user.
So it really screams efficiency, you might say.
It does, absolutely. Well, security and efficiency. If you look at the zero trust model, right, which everybody loves to talk about as a buzzword today, in zero trust, whether you believe there's 5 or 7 or 11, verticals in that, one of them is edge, and how do you protect the edge? And so we do solve for that piece of a zero trust model, and the way in which we solve for it is the assumption the edge device is already compromised. which that means zero trust, right? I assume it's already compromised, which, by the way, it probably is, because you probably bought it from Android or Apple. It's probably collecting some level of adware off that device. You probably have social media on there some way, and it's collecting some level of adware off the device. Or worst case is maybe you're not quite as responsible as we would hope you were, and you have something like TikTok on your phone, which is a substantial portion of the entire population, or you're an enterprising young AI enthusiast and you downloaded DeepSeek, all of which are backed by nation-state actor capabilities to which they can collect and control information sets. We don't want Department of Defense data existing on that edge device. We don't want those applications to be able to have visibility or interact with those kind of things. So that's why a platform like Hypori, especially for a BYOD environment, can provide that physical separation of CUI data or sensitive data, corporate data, manufacturing data, supply chain data, from all the things that are probably on that person's individual phone.
Well, thanks for some great information.
I appreciate you guys having us.
And our guest has been Jared Shepard, the CEO and founder of Hypori. I'm Federal Drive host Tom Temin, and you're listening to Federal News Network. Let's go back to the studio now for more on DoD Modernization Exchange.